Today we're covering section 1.1, and this is talking mainly about properties of real numbers. We're going to get into some other things as well, but we're going to start off with properties of real numbers. The first thing we want to talk about is what are the types of real numbers. And the first type of real numbers, we call these types subsets, but the first subset is what we call the natural numbers. The natural numbers are also known as the counting numbers. Those are the numbers that you learn when you first start learning how to count. 1, 2, 3, 4, 5, 6, 7, and so on, and they go on forever. The second subset of the real numbers, and again, a set is just a group in math, and a subset means a smaller group inside. So our real numbers are the set, and the natural numbers and now the whole numbers are subsets. So the whole numbers are all the natural numbers, including, and then in addition, we have 0. So 0, 1, 2, 3, 4, 5, 6, and so on. Then we have integers. Integers are all the whole numbers and then all their opposites. So all the negative numbers and all the positive numbers, but no decimals and no fractions. Then we have rational numbers. Rational numbers can be written as a fraction of two integers. Numbers like 1/2, which is 1 over 2. Numbers like -3/8, which is -3 over 8. Even whole numbers, or natural numbers, or integers, for instance, -5 can be written as -5 over 1. So rational numbers are numbers that can be written as a fraction, and the numerator is an integer and the denominator is an integer. And then we have irrational numbers, and the simple definition of these is it's just not rational. So it cannot be written as a fraction with two integers. So looking at these values, we've got the first one is -3 over 2, and on our calculator, if we type that in, it's simply -3 divided by 2, and we get -1.5. Now when we think of 1.5, notice we will go from the 0, 1.5 spaces to the left. So our first value, that -1.5, will be right there between -1 and -2. The second value is 1.7. You really don't have to do anything to this, but we simply count 1, and then we've got a half, and it's going to be a little bit more than a half. So in the positive direction, so to the right, we're going to get 1.7, and that's going to go, again, between the 1 and the 2, but in the positive direction. The last one that we have is the square root of 5, and you have to use your radical key. So to type in the square root of 5, like I said, you have to use your radical key. To get the radical key on your calculator, you have to use your second key. And then down here by the x squared, you can see there is a radical next to it, so we're going to type that in, and then we type in the 5. So that approximation is approximately 2.24 if we round it off to the hundredths place. So that's what we'll have to put on our number line. So square root of 5, when you round that off, it's approximately 2.2, and so that's going to be between 2 and 3, and that will go right there, between the 2 and the 3, but less than halfway. When you're graphing these, what I'm going to want to see is your approximations, and then where does your graph point go approximately. I'm not going to be super picky on it as long as you've got it in the right area. For this one, what we want to do is we want to compare negative square root of 0.25 and then negative square root of 0.01. Again, to do this negative square root of 0.25, we put in the negative. Then we have to use the second and radical key. And then 0.25, it's a good habit to close your parentheses, and we get -0.5. For the second one, we've got negative again, the radical key again, and 0.01. Close your parentheses, and we get -0.1. So those are the two values we're going to have to compare. For the first value, we get -0.5. For the second value, when we type that in, we get -0.01. 0.1. Now, this may seem odd, but a negative 0.5 is further negative than a negative 0.1, so negative 0.5 is less than. It's like thinking about owing somebody money. If you owe somebody 50 cents as opposed to owing somebody 10 cents, owing them 50 cents is worse, so that's less than negative 0.1. With our second one, we've got negative square root of 0.08. Now for this one, we've got negative square root of 0.08. So we type that in, close our parentheses. This one is irrational. We're going to have to round it off. So approximately negative 0.28. The other one that we're doing is negative square root of 0.1. Close the parentheses, and we get negative 0.316 or negative 0.32, and that's the number those are the two numbers we'll be comparing in this problem. And again, think about which one is worse since these are negative. Owing 28 cents is better than or greater than owing negative 32 cents. Some properties of real numbers. First of all, you have opposites. These are also called additive inverses. And the key thing with opposites is they have opposite signs. Another thing is they add together to be 0. Algebraically, we express this as A and a negative sign in front of A. But remember that negative sign doesn't really mean negative, it means opposite. So if you have your A value of negative 5, the opposite of that will be positive 5. Next we have reciprocals. These are also called multiplicative inverses, and these multiply together to equal 1. We've talked about reciprocals before. Algebraically, we write it as A and then 1 over A. With a fraction, we just remember that we can change the numerator to the denominator and the denominator to the numerator. So let's take a look at this example. We have 3/5. Well, if we want the opposite, that's a positive 3/5. We just need to have negative 3/5. And that's how we get our negative. For the reciprocal, remember the numerator becomes the denominator and denominator becomes the numerator. So this will become 5 over 3. Oh, and I've got them there. So those are our values for that one. This is on page 7 in the Algebra 2 textbook, but here's some properties of real numbers. If we let A, B, and C represent real numbers, first of all, A plus B and A times B are closed. Or I'm sorry, they're real numbers, so this is the property of closure. That means if you take any two real numbers and add them, the answer is real, or any two numbers and multiply them, the answer is real. Addition and multiplication are also commutative. Notice A plus B is equal to B plus A. You can switch the order around for addition or multiplication without changing the result. This is not true for subtraction because A minus B is usually not the same as B minus A. It's also not true for division because A divided by B is usually not equal to B divided by A. Next we have the associative property, and this just relates to how these numbers are grouped. You can group the A and the B together when you're adding, or you can group the B and the C together when you're adding without changing the sum. The same works for multiplication. Changing the grouping does not change the product. We have each addition and multiplication has an identity. So we all have learned since probably kindergarten that any number plus 0 is the number that you started with. The same thing happens for multiplication. Any number times 1 is still the number that you started with. So 0 is the identity for addition and 1 is the identity for multiplication. And then last, I guess not last, but inverses, we have an additive inverse. Remember we talked about that on the previous slide. A plus its opposite is always going to equal 0. For example, 10 and negative 10. And also for multiplication, A times its reciprocal is going to equal 1. Well, the one exception to that is a cannot be 0 because 1 divided by 0, which would be its reciprocal, is undefined. We cannot divide by 0 or have 0 in the denominator of a fraction. Finally, we have the distributive property, and the key thing we have to remember here is that this a, when you're multiplying and adding or subtracting in here, this a gets multiplied by the b, so now it's a times b, plus this a also gets multiplied by the c, so you also have a times c. The last topic we're going to deal with today is what is called absolute value, and we want to think about that as the distance from 0. So for this first one, we want to simplify the absolute value of -4, absolute value of 0, and absolute value of that product. So for the first one, the absolute value of -4, we want to think to ourselves, how far away from 0 is -4? And we know, if we think about it for a little bit, that -4 is 4 units to the left of 0. So the absolute value is 4, because that's its distance from 0. Next, the absolute value of 0. Well, how far is 0 from 0? No distance. So our absolute value there would be 0. There's no space between them. The last one, we have to first of all simplify it. -1 times -2 is +2. And then we want to think of how far is 2 from 0. Well, again, we think about it, and 2 would be 2 units to the right. So our answer is, the distance is 2, and the absolute value is 2. Now your actual absolute value does not have to have units on it, but again, I'm trying to emphasize here we want to think about it as a distance away from 0. The assignment that I'd like you to work on, you don't have to start it now, but you'll be working on it tomorrow during class. Section 1.1, pages 8 and 9, and you can see the problems listed there. I believe there are 15 problems, but most of them will not take very long. So you'll have some time to work on that tomorrow in class. I will be able to help you. You'll be able to ask your friends if you need some help. And we will take a look at those problems tomorrow. And then hopefully we'll be able to turn them in by the end of the period. Have a good evening.